Hello. These are some of database important interview questions, and some. This is a part one. Part one. So I'll be covering more questions on SQL or database. Um, what is the meaning of database or database system or DBMS? A database system or a DBMS is a software that ensures that the data in the database is organized, secure, and easily accessible. Like it's nothing but a system to organize, uh, secure, and easily accessing the data in the database. Which operators can be performed in operations? Which operations can be performed in database? We can do live operations like create, insert, update, delete, and select. Like this create, insert, update, delete, these operations are used to modify data in the database. Modify data in the database. Whereas select operation is used to get data from the database. In software terminologies, the above operations is known as CRUD operations. CRUD means create, read, update, delete. Difference between traditional third question, difference between traditional file system and database. In traditional file system, the data is unstructured, unorganized, unstructured, such as file which we normal file which we store. In database, the data is structured. For example, database your college database or your fees database. In your fifth semester, we had made a project known as a database management system. In that, we have used database. Some examples of database are MySQL. In high redundancy, in traditional file system, redundancy will be high because same type of files may present multiple number of times. Redundancy means same type of data or same type of files will be available more in large quantity. Lower redundancy in database, low redundancy will take place. It means the data in the database will be unique and it will not be same. It does not have a backup mechanism. If once a file has been lost, it does not have a backup mechanism. In Windows, we usually get a backup mechanism, but it's not a files. It's not a file. A file should have some technology to back up itself, not with the help of any Windows or with any operating system. So it does have a backup mechanism. If a data has been lost, it can be recovered from the production. In usually in development field, there will be a production database and there will be small database in each department. The data from here will be uh, shared to this department, each department which is necessary. If this data is lost, then the original data will always be present in the production. It does not have a backup mechanism. It is less complex. So a basic simple file structure is less complex compared to database. Whereas database is complex while creating it, altering it, updating or deleting it. It requires some software terminologies or some basic technical knowledge to operate a database. The system is cheaper. A simple file is easy to create, but is easy to create and implement. Whereas a database is costly, it could require multiple dollars to rent a database or start your own database. Some example is Google Cloud, Azure, and Amazon Web Services. Only one user can access the data at a time. If I am logging into this system, only I can see the file at a time. Whereas multiple users can access the database because the data is present in the cloud and not in some personal storage. To access the data, the user needs some attributes such as file names and file location. To locate a file and to access the data from the file, we need to first know the file name and then which location, or whether C drive, D drive, or F drive, in which location it has been stored. like no attributes is required. Basically, we just need the database name and we can perform all the operations with the same name. What is relational database? A relational database is nothing. Is it a type of database? Database is different and relational database is different. Where data is organized in the form of tables. Relational database is where the database is organized in the form of tables. And table means a table is nothing but a storage which has rows and columns where data is stored in rows and columns. Rows can also be known as tuples, whereas columns can be known as attributes. So this in SQL terminologies we usually use tuples and columns instead of rows, tuples and attributes instead of rows and columns. Okay. So difference between DBMS and RDBMS, database management system and relational database management system. So as you know, RDBMS, it is stored in table format. You know one of the difference. So if one is in table format, the other will be in file format. Okay. So here redundant data exists. Redundancy in database redundancy will also be present, but in not in large quantity. When we shift from database to RDBMS, redundant data does not exist at all. In relational database, no redundant data or same data will not exist. Less amount of data can be stored. In DBMS, only small quantity of data is stored. In RDBMS, huge quantity of data can be stored. Whereas RDBMS is less secure. DBMS is less secure, and RDBMS is more secure compared to DBMS. When we want to access some data from DBMS, it is little bit slow compared to RDBMS. So some of the example here is Excel for DBMS and MySQL for RDBMS. List down the various languages present in database. So in database, if you want to understand how we all you will already know this DML, DDL, TCL, and DML, but not aware when you are using it. So you'll be already you knowing it, but not knowing the definition. Okay. So there are multiple language in MySQL. So data manipulation language (DML), uh, data definition language (DDL), data control language (DCL), and transaction control language (TCL). These are four languages in MySQL. Data manipulation language. With the name itself, we can understand that we are manipulating the data with the help of this language. So this is a language we use to manipulate data using DML commands. Some commands will be present with the help of that. We will manipulate the data inside the database. The commands are insert, update, delete, and select. Insert, update, delete, and select. Data definition language. It's a language used to define structure and schema of RDBMS using DDL commands. So, data definition language, after a database is created, where it is used to create, first of all, database defines structure in the sense, if we are defining the structure, it means we are already creating it. If we are creating the structure, we know how to create it. So, in short, DDL can be used to create a schema of RDBMS using DDL commands. It's a language used to define structure and schema of RDBMS using DDL commands. The DDL commands include create, alter, drop, truncate, and rename. And data control language. It is a language used to manage access control and security of RDBMS using DCL commands. Why we are using always RDBMS is when most of the time we'll be only using RDBMS when it comes to SQL. So RDBMS, it is a language used to manage access control, like who can access the database and security. Data control means we can already make an idea that the control uh, is used is made for is used to provide a security to something. Okay, DCL commands include, there are only two commands, grant and revoke. The permission can be granted or the permission can be revoked. So these are the two commands. Transaction control language. It is a language used to manage transaction in the database using TCL commands. TCL commands include commit, rollback, and save point. TCL commands include it. First, TCL is known as transaction. Transaction is nothing but bank transaction. Bank transaction is only takes place with the help of RDBMS. Most of the time, RDBMS is being used currently for bank transactions. So TCL is used to uh, 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 manage those transactions with the help of these commands: commit, rollback, and save point. Okay, so next question is, what are ACID properties? ACID is an acronym, short form that refers to four properties to define a transaction. If these four properties are present, then we can say that the transaction is secure and the database is also safe. For a perfect transaction, these four properties must be present. Okay, so atomicity. A stands for atomicity. It means any transaction should be completely done or it should not be done undone. So if any transaction is taking place, it should be completed or it should not at all be done. See, there are two transactions. There is a transaction main transaction here. Okay, in this two transaction has been happening, the transaction T1 and transaction T2. If someone want to make this transaction atomic, then both of these transaction, parent child transaction, must be completed. Say if what is happening here is, first is 500. We are reading x value is 500 and we are removing 100 from it, from 500. The value of x will become 400. Okay, this is the first transaction. After the first transaction, if the transaction is um, closed or stopped or interrupted, then this transaction will be left out. The main motive here is atomic. If a transaction is atomic, then everything will go. Each and everyone will get an equal opportunity to execute itself. So y, the value of y is 200, and the if we are reading y and we have to add 100 rupees to y. After adding it, it will be 300. So the atomicity tells that if in a transaction all the transaction will be completed, or it should not only initiated at the first place. Consistency. Consistency means consistency means a database should be consistent or same. Make circle this same during beginning of the transaction and after completion of transaction. See, before beginning of transaction, there were some value, 200 plus 500 is 700. So before the transaction, the total value of the amount was 700, and after transaction, the value should also be same, 400 plus 300, it is 700. So of if both the values are same, we can conclude that this transaction is also, it is consistent also. Isolation. Isolation is nothing but if multiple transaction is happening concurrently or simultaneously, there will be some issue that if one transaction is halted and the other transaction of the same kind is not alerted, then there will be inconsistency in the database. So in order to avoid that, we will be converting these simultaneous or parallel transaction into serial transaction. This is the main motive of isolation. It is a property where multiple transactions running simultaneously appear to execute automatically and serially, even though they are actually happening. It is actually happening in simultaneously or concurrently. It is behaving like serially, because in serial we can get an idea that after one transaction is completed, the next transaction is initiated, so there will be no confusion of anything. We'll understand with an example. A value is 500 and B value is also 500. See, after we are multiplying 500 with 100. So after this, till here, the value of A becomes 50,000. Okay, till here, the value of A becomes 50,000. Okay, what happens if this transaction is interrupted due to some reason, and this B is not recorded in the database, is not written in the database? Then what happens in the next transaction? See, we are reading A, we are reading B, and after reading both of them, we are adding this, and what happens, we'll get a value known as 50,500. So this should not be the case, because in after reading B, we are removing 50 from B. If we remove 50 from 500, the remaining value will be 450 rupees. Okay, so the actual value should be 50,450 rupees. But what is happening? 50,500 has been recorded in the database, which is actually not right. So if this is the example I am showing you, because what happens when a transaction is carried out serially, oh sorry, simultaneously or concurrently. So what happens is, it is behaving, it is happening in concurrent way, but we are making it appear like serially. So one full transaction, it should be completed, and then the next transaction should be initiated. It will take some fraction of seconds, but it will be accurate for the database. No, the main thing what we use to do this thing is commit, command we will use. After one transaction commits, then next transaction should start. This will be an easy way to handle this type of inconsistency in the database. Durability. This property, durability, says that when if any transaction is recorded, like see, this thing is recorded 500, 50,500. So it is, even though it's wrong, but it is, if it's recorded in the database, then it should be permanent, it should be durable. If what happens if the power supply for the database shuts down, if this data is being erased, then we don't call that the transaction is durable. So for the transaction to be durable, we want that this record will be permanently stored in a database. So by this, we can know that the what the transaction is durable. So that is asset properties define a transaction. Okay, so transaction refers to a single unit of work that involves one or more operations on database. Okay, it's a single unit of work that requires one or more operations. See, one or more operations on the database. Simple definition. What is null value? Is it different from zero? As a programmer, we'll be knowing that null value is always different from zero. Zero contains some value, whereas null value is nothing. Null value tells that value is not available. So null value is different and zero is different. Zero value is different. Explain different levels of abstraction in database. The abstraction refers to the concept of hiding the complex implementation details of database system from the user and providing them this with a simplified view. Abstraction is nothing but we have learned abstraction in OOPS also. In OOPS concept also we'll learn about abstraction, polymorphism, um, encapsulation, etc. Like these are the things we'll be learning in OOPS concept. Abstraction, encapsulation. These are the things we'll be learning. So abstraction is similar in definition. Okay, similar in definition, and also the concept is also similar. But in database, we'll have some levels of this abstraction. Abstraction refers to the when some thing is being implemented, when a building is constructed, the complex part or the basement. The basement is already always hidden from the building who they are using, but only simplified view. Simplified view of the building is being present, is shown to the user. So this is nothing but abstraction. So there are three levels of abstraction, that is physical level, logical level, or view level. These are the three levels of abstraction. First, physical level or internal level. Physical level is also known as the internal level. It is the lowest level and it is closest to physical storage. If when there is a physical level, we can infer that it is somewhere physical storage is also near to that level. Okay, logical level or conceptual level. So it is an intermediate level. Logical level. Logical level is an intermediate level that provides user-friendly view of the data structure. Oh, it is a user-friendly or intermediate level. You can say that in simple terms. It represents data in tables and columns. How it provides a simplified view of the data structure. Data structure is nothing but it's a concept where we know how a data is being stored in the database, whether it's storing in row, columns, tables. In if for a simple user, for a normal user, if a data is stored in database, it will be a user-friendly data structure. Table is a user-friendly data structure for a normal user have who don't have programming knowledge. So we say that logic level is user-friendly level and external or viewer level. In physical level, it is close to database. Logical level, here the programmers or DBS, actually DBS will be working in logical level. So in view level, it is a level where users use the application or any websites or anything. This is a level closest to the user. It is concerned with the way in which the individual users view the data. So this is the three levels of abstraction. End of part one.